Think where secure communication is used. Browsing the web may come to mind first, but also factories, utilities, shops, and banks, and much more so governments and military and so on. They all rely on secure communication. Quantum computers pose a threat to the cryptography needed for all this secure communication and therefore to our modern way of life. While quantum computers are not here yet, someone could record encrypted data now and decrypt it once they are here. We can protect against this in various ways. But for highly valuable data with long-term confidentiality, quantum key distribution, in short QKD, can offer better security. QKD uses quantum mechanics to ensure it is impossible to eavesdrop on the key exchange and therefore allows us to produce keys that we can use to better protect data. This technology is complex and requires new hardware and systems which need to be tested and certified. For this, we need an infrastructure. This infrastructure is much more complex than normal telecommunications equipment. At TUE, we have the expertise to build this infrastructure and to offer testing. Therefore, we established the Quantum Communications Testbed NL, short QCT NL. Imagine fiber underground crisscrossing the city and reaching the automotive campus in Helmond, the high-tech campus on the other end of Eindhoven, and beyond to Walre. We place this novel technology in real environments and combine it with all the things needed to make it useful to secure communication. And also add everything needed to perform measurements. Something that could not be done in a live network. After almost 5 years of preparation, we launched QCT NL in August and now have a world-class facility that is open to anyone in industry and academia to work with us to test their developments. Whether that is a whole system or a small component within a system, and whether it is hardware or software or network protocols. At QCT NL, we have what it takes to test quantum-safe communications to make sure we can stay safe and connected. And we're even looking forward to the next step, interconnecting quantum computers. My name is Simon Rommel, professor at TU Eindhoven, leading QCT NL, and happy to be part of QCINed.